I'm going to walk you through kind of what I did. So the first one, it wants us to copy this line segment. So we have a given line segment and we want to make an exact copy of it. Well, all we need to do is put our sharp point there and put the pencil there, and then we go like, whoosh. And basically what we're doing is making a circle. So this then is the radius of this circle. And we don't change our compass, and we go over here and we make a whoosh, and then we've made the same circle. So that means that this distance has to be the same as that distance because the radii of the same circle are congruent, right? That happens a ton in these proofs. So if this distance is the same as that distance, what I've done is I've copied the line segment. I've created two congruent line segments by making them the radii of the same circle. All right, construct the perpendicular bisector to the segment. Okay, so we know we have this endpoint here and this endpoint here. And what we do is we make our compass more than half. And so we put our pointy end right here, and we take the pencil and we go roomp and roomp. And that distance and that distance are all the same, and then we don't change the compass and we come over to this point and we do the same thing that way. Oops, it's not gonna like me to make another mark. We make that mark and then we make that mark, okay? And what we know is that intersection has to be equidistant from the two endpoints, which means that little blue point and that blue point are both on the perpendicular bisector. So what we can do is we can use our straight edge and cut it in half. And what we've done is we've made a perpendicular line, which means 90 degrees, perpendicular, 90, and then we can put a right angle there. And then we bisected it. To bisect it means to cut it in half, and that means that this red point is the midpoint, which also means that that line and that line are the same. Okay? Perpendicular bisector, we're going to do it 1,000 times. If you look at just the marks, what you're going to see is there's just a mark. There's basically a circle, 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 circle. And those distances are going to be the same, and we can find the middle. All right, construct a perpendicular line that goes through the given point. Okay, this point is given, and this line is given. And all we need to do is make the compass and make the radius a little bit bigger than this line. So when we make our circle, this guy, we know that these 2 points are equidistant from that point. We can actually keep the same compass and then from here, make this line, and then from here, make this line, and then we know the intersection of this has to be equidistant from those 2 points. The given point was equidistant, and so if we connect the given to our intersection, we guarantee then we created the perpendicular bisector of those 2 points, which means we created a perpendicular line through the given point to that line. Extremely similar right here. We want to construct a perpendicular line through that little point, right? That point is the given point, right? This guy right there. That's the given point, and we want to make a perpendicular line through it. Well, all we got to do is take our compass, make it whatever we want, and go whoom, whoom. These points then, that guy there and that guy there, they'll be the same distance from the given point. We can make the compass a little bit bigger and then go whoo, whoo, up top. Now we know that this blue point is equidistant from the 2 points I made. Well, that point has to be on the perpendicular bisector. We know that the given point, that's the whole point, we wanted to draw a perpendicular through it, and then we connect. And we guarantee then that this line is through the point and it is perpendicular. Okay? This one is a little harder. So what we're going to do, follow the directions. It's going to say draw 2 chords. A chord is just a line starting from the circle and going and ending up on the circle, right? It's any line segment that joins any 2 points on the circumference. And what we're going to do is find the perpendicular bisectors, and it turns out that the intersection of the bisectors will be the center of the circle. So I did this chord, and I went here, and I went whoom, whoom, and then I went here, and went choo, choo. And again, the connection of this point here and this point here, I know then if I connect those, I found the perpendicular bisector to that chord. I do the same thing down here. Take over here and make a tick mark, and make a tick mark, right? And then those, and I do the same thing on the other side, and then those intersections have to be the perpendicular bisector of that chord. Well, if you extend the perpendicular bisector of one chord, the perpendicular bisector of another chord, you will in fact for sure find the center of the circle. Okay, and that was what we wanted to do. We wanted to find the center of the circle using perpendicular bisectors, right? And all we had to do was draw two chords and find their individual perpendicular bisectors, like we always do. Again, this question is really similar to this one, which is similar to this one, which is identical to this one. Being able to construct a perpendicular bisector. Connect. And really what you're doing is you're just finding two circles, and those two circles intersection, they intersect at points equidistant from the endpoints. All right, let's go down to number 6. Number 6 is probably one of the hardest ones. What we want to do is we're given these 3 points, the 3 black points. Well, now they're going to be blue. And we want to find the actual circle that goes through all 3 of them. And what we want to do is we just got to find 2 connections. So I said draw this one and draw that one. And then you want to find the perpendicular bisector of those, which we just got done doing. Find tick marks, tick marks, tick marks, tick marks, connect, connect. And it turns out then the center of the circle, again, is the perpendicular bisector of those chords. Well, once you know the center, well, then you can find the radius. So the last step here is to take your compass and make it exactly this distance, which we know is the radius, and then make it go around. And it'll go through all 3 points because all 3 points are the same radius away because the radius or the radii of the same circle are all the same length. All right, copying an angle. You're going to set your compass, whatever distance you want, and go ahead and make this line, and then come over here and make that same line. These have to be the same. That distance and that distance and that distance and that distance have to be the same because, well, they're the radii of the same circle. And then what I have left to do, I'm going to erase that. I'm going to put my pointy edge here, and I'm going to put my pencil here, and then I know that distance. Well, then I come over here, pointy here, pencil here, and make that line. Well, all I've done then is make sure that this distance and this distance are the same, but if this distance and those distances are the same, that angle will have to be the exact same angle as that angle. And so what I've done is I've created an exact carbon copy of the angle. All right, same process here, except now I'm going to use copy an angle to create a parallel line. So the first thing you need to do is you just need to draw this. You just draw that line, right? That doesn't even mean anything. You can draw at any angle you want. You just draw that through that point. And then what we're going to do is we have an angle here, and we're going to make the same angle here. Because if these 2 angles, that angle and that angle are the same, it will turn out that the lines will be parallel. Turns out that the 2 blue angles are called corresponding angles. And congruent corresponding angles, meaning equal corresponding angles, will force the lines to be parallel. So I put my pointy end right there, and I take the pencil and I go, and then I put the pointy end here, and I go, that guarantees that these are the same. But if these are the same, what I can do is the same thing I did above. I can put the sharp edge there and the pencil there, and I can get that distance. Well, all I do is put the sharp end there and go with that guy. And then it's the exact same thing. This distance and that distance are the same. So that forces this angle to be the same as that angle. And then I can connect the dots. And I guarantee then the blue line is for sure parallel, same slope, to the black line. Again, constructing a parallel line by copying an angle. So this question and this question really, really, really are similar. Same thing. Circle, circle, measure, make, connect. It's that easy. All right, construct a square. The first thing I did is I extended this line a little bit. So extend that line, okay? You can make it red and you make it whatever, make it dashed. That's not part of the original thing though. And I can extend lines because I can take this point and extend through that point. After that, I take my compass of any radius I want and just go a circle around here. But again, I'm only making that part and that part. The blue is now equidistant from there. Well, now I do the same thing I've done 5 times. I make a perpendicular bisector to that. So make your radius a little bit bigger. Up here, whoom. Oh, it won't let me. Whoom. The intersection of those must be on the perpendicular bisector, which means I can take that original point and go way up, and go up pretty high. Okay? I've now for sure made that 90. Now what I can do, let's get rid of those. So I know I have this black line, and I do for sure have this line. It might go all the way up. I don't know where to stop yet, but I do. This black line needs to be the side length of all my squares. So I can just put my pointy end here, and the pencil here, and the pencil here, and I know that distance. So don't change that distance. And so I can then keep the pointy end here, and I can go up here. I can go around. That distance has to be the same as the square. I can go, and I know that distance has to be the same as the square. And then on that line up there, I can take it, put my pointy end there, and I can come over here and make that mark. Oh, well, let me do it. Oh, well, if I start here and go that way. Well, that distance, that distance, that distance are all the same distance as that distance. So now I have a square. I have all 4 sides are the same, and I know that guy is 90 degrees. That will be enough to guarantee that that thing is a square, because if that's 90, that'll have to be 90, which will make that 90, which will make that 90, and then I'll have a square. I'll have a quadrilateral that has 4 congruent sides and 4 right angles. All right, the last one is the easiest. Don't overthink it, right? We know this distance, so just make that your compass distance. If you make that your compass distance and then put your pointy end here and you go like this, well, then this is your compass distance. Put your pointy end here and make the other tick mark, that one. And then that distance is your compass. Well, all 3 of them are the same. Well, now you got an equilateral triangle. So number 12 is the easiest. It's just connect, done. Okay? Please practice these 12 constructions. A whole lot of them go back to perpendicular bisectors or just creating perpendicular lines. They all do eventually go back to this major fact. You are using the fact that you are making circles and that the radii of the same circle are congruent, and so we know lengths are the same, so we can end up proving angles are the same, is really important. But hopefully this video helps walk you through. I gave you a practice version of this, but these 12 constructions are certainly important to know, moving forward.